This device, which stubbornly refuses to light with a simple match, is no ordinary stove. It is a pressurized kerosene jet stove, a marvel of mid-20th century Argentinian engineering from the Volteno company. Time has rendered it completely inoperable, its inner workings seized and its surface tarnished. Today, a master restorer will use time-honored techniques and meticulous craftsmanship to undertake its complete and total restoration. While this pressurized stove shares a similar three-part structure to a standard one, a fuel tank, a burner, and a frame, its key difference lies in a sophisticated pressurization system. A standard kerosene stove relies on the simple capillary action of a wick to draw fuel. This model, however, uses pressure to deliver its fuel. Below the burner sits a preheating cup, a critical component. To operate it, the preheating cup is filled with a starter fuel and ignited. The resulting heat vaporizes the pressurized kerosene within the burner tube, which is then forced out through a jet nozzle and ignited into a powerful flame. The part being disassembled now is that very preheating cup from beneath the burner assembly. While the process sounds complex, vaporizing the fuel allows it to mix more efficiently with air, resulting in a hotter, more stable, and more evenly distributed flame. Interestingly, if you were to replace the burner head with a different nozzle, this same technology could be used as a powerful blowtorch for industrial applications like glasswork. With the theory understood, the restorer has already moved on to polishing the brass burner and preheating cup, having first retapped the threads of the mounting hole with a self-tapping screw. Next, he addresses the burner's feed pipe. Using a special jig, he cleverly turns his power drill into a makeshift lathe, allowing him to evenly sand and polish the pipe back to its original brilliant shine. Beyond the main body, the intricate vents and gills of the burner head must also be meticulously polished. This component is the evaporator rod, more commonly known as the flame control valve. Its purpose is to precisely regulate the amount of vaporized fuel entering the burner, thereby controlling the size and intensity of the flame. It's designed for easy disassembly to allow for routine cleaning of carbon deposits. Fortunately, the valve itself is undamaged, requiring only a thorough polish before being treated with a protective hot bluing finish. The main fuel line also undergoes the same intensive polishing process. This isn't just for cleaning. Years of corrosion have left deep pits in the surface, all of which must be painstakingly sanded away to achieve a perfectly smooth finish. Once a mirror polish is achieved, it's set aside for the next stage. Now the restorer carefully applies heat to desolder the three support legs from the main fuel tank. These steel legs must also be stripped of their rust and pitting through intensive sanding. Their final protective treatment will be addressed later in a dedicated step for all the steel components. Attention now turns to the pressurizing piston pump. The main issues here are a hardened, useless leather seal and a worn-out mounting hole on the pump cap. To fix this, a new leather seal must be custom-made. A piece of leather is cut, soaked to make it pliable, and then pressed into its cup shape using the piston itself inside the pump cylinder, where it's left to dry and harden. After 48 hours, the perfectly formed leather cup is removed, trimmed, and drilled. Because it will be in contact with kerosene, it must be waterproofed by being saturated in hot paraffin wax. The piece is then baked, allowing the wax to fully penetrate and solidify within the leather fibers, creating an impermeable, durable seal. Next, he tackles the heavily worn pump cap. After cleaning up the edges, he carefully restores the original knurled texture on its grip. To repair the enlarged mounting hole, he brilliantly repurposes an old Argentinian brass coin of a similar size to serve as a patch. The coin is sanded to the perfect diameter, soldered securely in place, and then drilled to create a new perfectly sized hole. After a final, meticulous polish, the pump cap restoration is complete. The remaining small brass components, like the pressure release valve and the fuel cap, are also polished to a mirror finish. Finally, he turns to the fuel tank itself. Fortunately, it's free of dents or cracks, requiring only a thorough sanding and polishing to restore its beautiful brass luster. Now it's time to address the steel parts that were set aside earlier, which require a special protective plating. First, a resist pen is used to protect the brass sections from the upcoming chemical process. The parts are then given an acid bath in 19% hydrochloric acid. This pickling process not only removes any final traces of oil and oxides, but also activates the surface for the electroplating to come. The first round of plating will be a layer of copper. Using a 10% hydrochloric acid solution as an electrolyte, the part is connected to the negative terminal and a copper wire to the positive terminal. A 6-volt DC current dissolves copper ions from the positive anode, which are then deposited onto the surface of the steel part at the negative cathode, completing the first layer of copper plating. After removal from the acidic bath, the parts are immediately neutralized with a baking soda solution. This initial copper layer serves as a crucial intermediate plating, improving the adhesion and quality of the final nickel plating. The nickel plating process is identical, simply swapping the copper anode for a strip of pure nickel. Because no chemical brighteners were used, the resulting finish is a bit dull. However, based on past experience, adding a common household item like saccharin can act as an effective brightening agent. With all components now fully restored, the final assembly can begin. First, the 3 newly plated support legs are carefully soldered back onto the fuel tank. The rest of the assembly is a straightforward, satisfying process requiring a steady hand and a keen eye. Here, a high-temperature graphite lubricant is applied to the threads. This prevents oxidation and ensures the threaded components will never seize up from the heat. With the final control knob secured, the restoration of this mid-century Argentinian pressurized kerosene jet stove is officially complete. Let's take a moment to appreciate the incredible transformation. The difference between before and after is truly night and day. Now it's time to fuel it up for the final demonstration, using kerosene for the main tank and alcohol for the preheating cup. A brilliant, powerful blue flame roars to life. A piece of industrial history, once destined for scrap, is now ready to burn brightly for decades to come. Thank you for joining us on this restoration journey.